Okay, I'm recording now.
Okay, Marcelino, go ahead.
Okay, hello everybody. Good evening. My name is Marcellino Gemelli. I work for Bosch Sensortec. I am normally based in Sunnyvale, right, when we go to the office. But of course, who knows when we will go back to the office. I'm still based in here in Silicon Valley, though. So I'm actually calling from Mountain View. So maybe a couple of words on who is Bosch Sensortec. We are a wholly owned subsidiary of Bosch. We started the MEMS, the microelectrical mechanical systems production about 25 years ago, and we have 10 billion MEMS sensors produced. And we have our own fab, and we're one of the inventors of a fundamental MEMS process called the Bosch process. We are a private company, so there are no official, we are not required to report our data. But this is what the analysts say for us. We are the #1 motion sensor for consumer electronics MEMS. Again, we cannot confirm nor deny this assertion, other than saying that, yeah, it's likely very close. So our portfolio is based on orientation sensors made up of accelerometers, magnetometers, and gyros, and all the combinations, right, of the standalones. We have environmental sensors, pressure, temperature, humidity, and air quality, and what we call the smart sensors, the ones that also have some built-in smarts, right? Some built-in processing capabilities. That I'm going to talk about that a little bit later. In order to get close to today's topic, I wanted to touch base on what and how our sensors, how they help the autonomous vehicles. And given that we are a consumer electronics company, I will look at two cases of autonomous vehicles in the consumer world. One is drones, right? And let's see how the MEMS improve the drones. Well, first of all, you need to have accelerometers and gyros that have offset and sensitivities that are under control, right? Because they determine issues with the orientation in the drones themselves, and they might, if they are too much out of control, they might also introduce instability, right? So it is important that these offset and sensitivity parameters do not drift over temperature, because then they cannot be compensated by the unit that is called AHRS, which is the altitude heading reference system. Right, so what you want is a low TCO, low temperature coefficient of the offset, a low temperature coefficient of the sensitivity, and as much as possible vibration rejection. So that's carried out by the actual MEMS design and the design of the packaging, so that the vibration of the rotors and other vibrating elements in the drone are rejected. So this is how we take care of the drones when it comes to stability control, but there's also altitude control that is taken care of increasingly by pressure sensors. Right, the pressure sensors are more and more often built into the drone, and they determine they help stabilize the altitude. This in conjunction with the IMU, with the gyro and the accelerometer. And what you want is a very high relative accuracy, right? So that you are able to track your altitude. And once again, the temperature dependency must be as low as possible, right? Because the temperature fluctuation inside the drone will vary widely. So these these sensors help stabilize drones, help them perform the functions that they are designed for. So think about the viewing and the panning of making videos and keeping the image stabilized. You want a drone that is easy to operate, but at the same time very stable. If we take another example of autonomous vehicles, are the vacuum cleaners, right? The vacuum cleaners, such as the Roomba, just to give an idea which kind of automatic vacuum cleaners we're talking about. And we have similar requirements for stable gyros and axles, as you would expect. But did you ever notice, however, that sometimes even the smarter robots get stuck in a corner of your house? So what is happening there? Well, one of the problems could be the magnetometer, right? The magnetometer is seeking the magnetic north, and it is designed to do so, right? But the problem is it's so sensitive that it will pick up other stray magnetic influences inside the office, in this case, right? If you look at this map, as the robot goes around, it will, we sometimes refer it to, it will fall in love, right, with some ferromagnetic elements or let's say items that generate magnetic fields. We call these hard iron, right? Think about magnets inside the speaker, or permanent magnets inside the speaker or inside the motor, or soft iron effects such as batteries, antennas, and window frames that deflect the magnetic fields of the Earth's magnetic field. So this will create a fluctuation in the perceived magnetic north. And in the graph up there, you can see how the ideal no offset behavior looks like, and the hard iron is clearly a specific offset, and the soft iron comes up as a deformation of the field. So how do you do to do this? How do you take care of these? Well, for the soft iron compensation, you make sure that during the design process, you take care of you try to introduce some parallel magnetic fields for the design and the calibration of the PCB. Right, you find some forbidden zones where you cannot place your magnetometer, and well, where you should not place your magnetometer, so that it's not influenced by the magnetic deflections of the other elements. For the hard iron, you might be familiar that, for instance, in smartphones, you are being told to carry out a figure 8. But this is clearly to orient the phone in different directions so as to detect the offset, and then by software you can eliminate it. However, this is not possible in a robot, right? You cannot have the robot flipping over on itself. So you need to develop some software that takes care of this with more traditional motions that are natural for the device itself. So you can see how very quickly, the importance of the sensor itself. So the sensor itself is important, its performance is important, but you also need software. Right? You also need software that over the course of time, over the course of the MEMS, at the early ages, we were just happy to have some smart interrupts, right? Inside our, coming from our sensors, and that was all we requested from our sensors. Moving forward, our sensors became smarter, right? We implemented some algorithms in there, like the Kalman filters for sensor fusion, and that is the kind of a second wave, which is a bit where we are today. But where we are going is where we actually have an AI and some ways of generating, right, automatically forming the software, right? So through some forms of software synthesis, you are able to generate some let's say edge AI processes in order to have the device and in the end the system learn about its specific environment and be able to fine-tune the algorithm out of it. And the other benefit here is that you also want to reduce, you want to restrict the amount of time that that it takes you to develop the algorithm. But clearly, this edge AI, there are some other benefits that come with that, and we'll be happy to discuss in the Q&A. One of them is personalization. So once you have the data being processed on the edge, and again, as a sensor vendor, for us, the edge is the sensor itself, right? No co-processors, is really inside the sensor. And so this means that each sensor will personalize, will adapt to the user's to the user's behavior. And at the same time, you have the advantage of the privacy, right? When you are not, since you are not sharing the data with the cloud, but even with the application processor, the data is kept private. And you also have benefits in latency, right? You reduce the amount of time that it takes to transfer the data with local processing. And overall, you have an improved battery life, because transmitting the data, processing the data at a higher level processor most of the time is not as power efficient as on the edge. I'd like to focus a little bit on the kind of skills that engineers need to actually introduce AI. So we are seeing more and more that that you need the competence of three factors, and we call this the triad, right? You need to understand the AI algorithms themselves, so you need to have some experts in AI. You need to have the ability to collect the data from your systems, right? And this is often overlooked, right? And this data is then used for training the AI. But what is also just as important and often forgot is the full end-to-end domain knowledge. So you don't, it's not enough to just know the end use case or just the sensor. You need to be able to embrace the full end-to-end model. And that is what we call the triad. And more often than not, you will see that some companies, some groups are actually just focusing on one or two, and then they have a hard time introducing AI, edge AI into their system. So in the end, what you want to develop is also a community, and this is our small contribution, right? As Bosch Sensortec, we have more than 16,000 people already connected to part of the community, which is a community that that not only uses our portal for individual support on our sensors, but is actually starting to share some of the information, some of the also training data to achieve let's say this end-to-end knowledge that needs to be developed. And we are moving forward, right? For instance, in Central Europe, we are creating a hub that we call the Artificial Intelligence Valley in Central Europe, where let's say at the end of next year, we expect to have more than 700 people from academia, from students, from industry, just being there in let's say shoulder to shoulder, COVID permitting, to create this ecosystem. So that's my pitch. Hopefully, it has given you an idea, let's say, a perspective from what we're doing in the consumer electronics. We gave a couple of tastes on the markets where we're looking for. We showed the importance of good performance of the sensors, but at the same time, that you cannot forget the fact that we are making hardware, but people are buying software, right? So so whether that software is automatically generated or part of a bottom-up development, that's what in the end people buy. Okay, so that's it from my side, and we can take the questions now or later. Thank you.
Okay, let's postpone the questions to later if possible. So let me just say a couple words before the next speaker. So to tie this back to like an autonomous vehicle, I just looked up, for example, like the Cruise, which GM is about to start testing out, having these cars literally with no one inside. So like a level 4, level 5. Just a Cruise is a little electric car. In just one car, it has 14 cameras, 3 LiDARs, and 21 radars. Okay, so if you add that up, that's like 35, right? It's 38, I guess. So just counting those, you already have all these different sensors. And then, of course, the question is like, which is correct, which is not correct, what is doing what? And so what are they using these for? Like, for example, the radar, they're doing 8 for long distance stuff to see what's maybe half a mile away, a mile away. Then they have like 10 that are like seeing if there's a dog next to it, if someone is behind it. Then there are 3 that are wide field, because the narrow ones you can't catch except for a very small angle. So they also have those 3. So when the car is turning, so the angle is changing very fast. It's going up a hill, the angle's changing fast. They use the 3 wide field. So again, 8 long range, 10 short range proximity radars, and 3 wide field. And then I'm not counting other sensors they have, like depending on what car you have, some of them also have infrared sensors. Some of them also use, so those are like thermal sensors. They also have ultrasonic for like parking, all kinds of stuff. So there's some problem already at the sensor level. But if we go up in complexity, we're next going to hear from Michael. So he's talking more about if you get to the Internet of Things and you want to connect all these things together, which are like completely unrelated stuff, how do you connect it? So Michael, you have the floor.
Okay. Let me share. Can you see the screen?
We can see it. I can see it.
Okay. Introduce a little bit of myself and about Lenovo Connect. I'm currently working for Lenovo Connect as the general manager of Intelligent Connected Vehicle Business Unit. I think all of you know Lenovo, and I'm using ThinkPad X390 right now. And what Lenovo Connect does is we put a 4G module into the laptop so that I can go anywhere I go, and I can, as long as they have 4G connections, then I don't have to search for the Wi-Fi or anything. I can just get online at any time. So this is very convenient. Before that, I worked for telematics industry for many years, and 2008 I was sent to Shanghai and to launch the Shanghai OnStar in China, and after that I've been working in this industry. And for all those years that I see is the telematics industry has grown tremendously. That I am really glad that I saw the topics bring it up. What about the data? Should we consider about the privacy of the data? And those are the things I think it's very interesting topics that we talk about today. So I'm going to talk about a little bit about the architecture of the telematics system, and then going through the data that we look into and see if we have any how we gonna protect the data. This is design that made by the it's called NGTP Group. 10 years ago that they released the version 2.0. And the NGTP Group is actually made by BMW and Wireless Car and some other European companies, that they try to set up a standard for the telematics. I can say the standard is set up successfully, but lots of companies, actually, especially European companies, also including like Chrysler, is also following this pattern to design their system. Although it may have some performance issue, after 10 years, it probably is become pretty legend system, but at least it gives us a way that we can discuss the components in the telematics system, so that we can talk in the same language. Otherwise, I will have a trouble to describe, because I don't want to talk about like GM OnStar systems, what's in it, and we can't really discuss about it. So the system that the telematics system is not, it's a really combination of lots of things. And we just heard people talk about sensor, that sensor actually collects data. But when you get the data in the vehicle, and we need to transfer it to somehow to the network, we call it telematics system. We need to data transfer back and forth from the vehicle to the cloud, and then we can get services out of it. And so all the systems on the vehicle, we call it telematics units. We call it a TU. It's an on-vehicle system. And when you get back to the network, and we need to process data, and the connection between the vehicle and the cloud, we call it a dispatcher. And the dispatcher, the function of the dispatcher is basically doing the communication between vehicles. And after that, we have the data going to the service handler, which can process the data. And then after that, it's a service integrator that can connect to all the services like call centers and other third-party services. Then we can get the services back to the vehicle, so that it's complete circle of the service onto the vehicle. So with this architect, we actually connected the vehicle with the network and the services after that, and so that we can have the whole system connected together to work with each other. And later on, we will talk look into the little detail of the system. And nowadays that we talk about 5G, and we know 5G is low latency, and it's very fast speed. And with that, we actually made a lot of things possible, because with 4G and earlier network, and every time we transact data from the server to the vehicle, we talked about the communication speed to be like in seconds. And but with 5G, we can communicate just in milliseconds. With that fast speed, that we can have a lot of autonomous related technology work. Give you an example that the traffic lights. For autonomous vehicle to get the traffic lights through the just using the vision, it is very difficult to make it accurate, because the traffic lights could be anywhere. And it's very easy to make mistakes, and it's a big issue that all the autonomous companies need to resolve. And with the traffic lights, it's standing there. It's basically, if you can turn it into a signal that can send it to the vehicle without the vision option, it will make it a lot easier and a lot more accurate. And also, if you can get the signal a little further, then you can react a lot much better and much safer. So that one of the things that we are Lenovo Connect work is we actually worked with autonomous company in China, that we try to get the vehicle connected to the traffic lights. And to make that work, we have put a 5G, it's called roadside units, that that connected to the traffic light, and it transmit data through the 5G station with the vehicles, so that it can send the signals of what kind of lights to the car, that the car can know what's going to happen, or what is the current traffic light, even in a distance. Then so that it gets much easier to know, without we have the vision to analyze, to get the results of if it's a green light or red light. And with this technology, potentially, the technology, we call it the cellular vehicle to everything. Basically, it's a V2X. And for the traffic lights, it's actually the infrastructure. So it's really a V2I technology. And with this, potentially it can achieve a lot more than that. We can have multiple vehicles that, in distance, we understand what the light's going to be on the way, so that you can make some calculations, so that you can, when you get to the traffic lights, maybe you can keep green lights, or the potential is huge. so this is how the 5G can bring to us. And also the 5G with the fast speed data transition speed, that we can also benefit with lots of other things, like we can have we can upload and download data for like the ADAS or the some high quality entertainment information and some video information and some of the services that we see in China, we have it's kind of like the car, what is it called? We in China there's a company called Didi that they can manage the cars to function as a taxi. They can have some monitoring systems in the car so that it can make sure the services are they can make sure the good services, and they make sure the passengers in the vehicle are safe. But meanwhile, it also brings up the problem of privacy. So if you're sitting in the car, basically you've been monitored the whole time. So that's some issue that we probably need to discuss in this event. Okay, by looking into the data that we collected and we utilized in the telematics system, basically we have two kinds of data that we used. One is, we call it the dynamic data, and the other is static data. The dynamic data is coming from the vehicle, and it could be the speed of the car, the location of the car, your tire status, all your components status, how many gas do you have? Basically, it's all the data collected from the vehicle. And the static data is that you don't collect it from the vehicle. You get it from some other resources, like the driver's information, the car module, brand, when you purchase it, do you have the services for that, and all the information from the car dealers, from other resources that we collect. And when you provide services that you got the dynamic data from the vehicle, and it's I just mentioned about, you get through a dispatcher module in the server, that it first need to authenticate the data, it need to decrypt the data, that the data has been encrypted before transmit to the server. And after that process, you go to the service handler, and the service handler actually needs to, it's called an enrichment process, need to combine the static data and the dynamic data together, so that when it's sent to the request for the services, you can have a complete data that needed, required for the service. For example, you have emergency call to the call center, that the call center advisor will be able to get your location of the car and get your personal information so that it can process for the emergency service, and because that, so you need all the data combined together to send it over. Meanwhile, if it also prevents unnecessary data to going through the third party. For example, if you only just need some point of interest from the service, so you only need to send the location data. You don't need to send all the car status. You don't need to send all those data to the location service. So it's depend on what kind of service you require. It will process the data so that it fits the needs. And after that, the data will be sent to the service integrator, so that the integrator will communicate with lots of internal or external service providers to complete the whole process. And then you send out a request, you get the response, then you send it back to the vehicle to complete the whole process of telematics service. And when we go through all this, what I'm trying to say is that the data process, the whole process of data process has a control function in the service handler, which is gathering the data from the vehicle. Then during the process, during the enrichment process, it's also function to save the data, restore the data to the database, and get necessary data from the database. The dynamic data from the history and the static data, combine it together and to the service providers. And so the service handler is really important for the when we need to protect the data, and we need to know how to manage it, and to block some of the data from misused. All right. Then we look into the data itself, and of course, for the privacy that we need to protect, we are looking into the sensitive data. And the sensitive data, including the say, if you have some personal information, those are the other things you don't want other people to know. That many of the static data is actually quite sensitive, but the data when we talking about the privacy of data, the policies that we actually been talking about for years, and there is right now, I believe there is a policy and procedure out there to protect existing data through the traditional IT way. That you're on the internet, you have your credit card numbers, and all those are protected. And I'm not too concerned about those. What we really need to concern is the dynamic data collected from the vehicle, because it's so new and there is no mature policies, or lots of people have not really considering about those. Just say your location. We actually have a joke when I was discussing with the OnStar staff, that I said if you have the car location, you have the location, then probably say you went to a bar and get drunk, and next morning you can't remember where you parked the car. Then you probably want to call OnStar, say, hey, where's my car? I need to where it is. I forgot. And after going through the telematics, they know exactly where the car located. They can just tell you, then you can find your car. But what if it's not you, it's your wife? She wants to know where you've been, and you may get into trouble out of it. So, so there is a policy actually in Shanghai Ansha that only the police can get the car location. The individual cannot just ask for where that vehicle is located, and this is a protection of the privacy, and now we have the telematics system turned on. Then basically everywhere you go is recorded. And also, I just mentioned about some services that you get onto a kind of like taxi, and you drive somewhere, and you get used to, maybe you have some discussion with your friends on the vehicle, and you didn't know that there is a recorder that recording all your conversations and everything. Then where that data goes and will that be misused? That's some concern that I think nowadays that we need to look into, because it wasn't a concern before. And right now, I think the legal system is not. It's definitely something that we need to look into. And considering the unique case of the potential sensitive data from the vehicle recorded, we cannot just say, okay, it's private data that with all the tracking of the vehicle is belong to personal, that we cannot just using it. You have to remove it, or you have to clean it up. Well, consider this case. Well, with artificial intelligence, that the machine learning process, it takes a lot of the resource data to learn the process. And also, as an example, the voice recognition, that especially the voice recognition on vehicle, that it needs to take time to get better and better. And guess how they training their system to be more and more accurate. They use a lot of data, and where the data comes from, probably just come from the system that they provided services. And just like Google, and they all the wording, all the searching wording you typed in, it's being used for big data learning process. And what are we going to do with all those? Should we just say you should not sharing all the privacy data, and you should just get all the data removed? Then probably we cannot get as far as where we go right now. But how can we make sure the data is not used against personal interest? In China, the Chinese government actually requires all the OEMs to upload the location information for all the electric cars, so that they can get the government fund out of it. Well, there's a reason behind it, because there's people that they said they sell the car, but they didn't, and they just try to get the money. And so the government need to monitoring to make sure the vehicle is on the road and is working. But is this against the privacy? I don't know. The European government actually set up the GDPR regulation to protect the data, and so people are looking into these things. I don't know how much how we look into how in the United States how those data was protected. I'm not sure. So basically, I just talked about the technology of collecting data, processing the data, and how it's being protected. I think we probably also need to discuss. It's something I can't just answer. Thanks.
Okay, thank you, Michael. So if you look at all the data that's moving around, question is who is going to move it, right? So for the longest time, there was a standard called IEEE 802.11p, which is called DSRC. So this is the one for short-term transfer of information. But it's been around for, I think, maybe even 20 years, and it's not really popular. So people realize that we need faster and broader pipeline to transfer stuff. So today, and this is where 5G comes in, as Michael mentioned. So there's a working group, a 5G AA group that now has over 140 members, and they call it CV2X. So basically, this encompasses the old V2I infrastructure, V2P, pedestrian, V2V, other vehicles. So they're trying to tie everything together so that they can transfer all of it. But then the problem is that some of the companies already invested in the old 802.11p or the DSRC, and they don't want to go to the new one. So for example, Toyota wants to use that old one. And NXP also wants to use the old one. And their point is that, we invested all this money and effort, so it's not fair to just jump to something else.
Right.
So the question is, what do we do then? And then the other thing too is that there are actually some companies who don't even like the CV2X. And some of these are very big companies. There are three that I think I'm aware of. One is Waymo, one is Cruise, which is the GM, and Tesla. So these three, pretty dominant companies said, we don't want anything to do with CV2X. So it's hard to say. Now, the Toyota and NXP have a valid point because the 802.11p uses 5.9 gigahertz. And as you know, around the world, they don't use the same part of the spectrum. So one problem with 5G is that in China and in the US, they don't use the same part of the spectrum.
Right.
So these Toyota and NXP is saying that, look, we're not going to keep doing this unless you guarantee that this spectrum reserve of DSRC will stay there. And I think nobody has actually said it will stay there, because if it will be reallocated for 5G or something else, then they're toast. Then all the investment is for nothing. So the next speaker, Nageen Himayat, has done a lot of work as to how best to connect all these vehicles, and predominantly 5G, highly technical work on the wireless side of it. So of course, the good thing, as has been mentioned by Michael and others, is that once you go to 5G, now you're like cellular based, and also you can do very quick transfer. And of course, the problem with 5G is that you have different formats, 1, 2, all kinds of stuff. So you have to trade off between speed and breadth, width of your broadband. So there's that consideration. And of course, there's a lot of known problems with 5G we can talk about later. But the question is that once you open a huge pipeline, the privacy issues become 10 times worse because everything's moving very fast and everywhere.
Yeah.
So Nageen, you have the floor. Thank you.
Thank you, George. So yeah, just a little bit of introduction. Can you see my slides? This is just my intro.
I need to stop the sharing. Oh.
Can you see the slide?
Yes.
Yes.
Okay, awesome. So thanks a lot. I think this is a pretty interesting panel. So I'm Nageen Himayat, and I work for Intel Labs, where my background, as George said, is mostly wireless connectivity. But now I lead a group which is focused on intersection of distributed learning and wireless, as well as data-centric protocols for next-generation wireless networks. So I guess this topic of telematics, 5G, and privacy, I belong sort of in the middle, but looking towards, how connectivity intersects with these topics. As George actually emailed us so many questions, and I felt like this is a very complicated topic. So I myself would probably just speak to, since I come from the labs, I will speak to what's next beyond 5G and how this may relate to the topic at hand. But a lot of detailed questions, perhaps, we can discuss them, but I won't be able to answer them. I also want to acknowledge my team and my colleagues, as well as a few universities that we are actually collaborating with for some of the projects that we're involved in. So we are supposed to report this legal. So as I said, basically our work focused a lot on advancing wireless networking with 5G. But now 5G is now being deployed. So the question is being asked in terms of what's beyond 5G. And I'm going to focus on three different topics which are somewhat related. So first of all, most of the wireless like 5G, Wi-Fi, and so forth, the design of wireless interfaces tends to be designed on its own, with the requirements being derived through, what applications may run on this. So what we wanted to look at is, especially in the context of autonomous systems where, some of the telematics applications reside, can you design wireless networks and autonomy together, and what benefits that may bring to you? So that's one topic that we've been researching. I will talk a little bit about that. And then, of course, I think if the previous speaker also mentioned, and I think a lot of people are now working on this problem, is that the beyond 5G networks, or beyond 5G networks, if you see, are so complex that deploying them and managing quality of service on such complicated network is pretty difficult. So people are now looking at AI and machine learning tools as a way to solve that complexity problem. So I wanted to give a few examples of how that might relate to this topic. And then finally, I would like to highlight the topic that I am personally working on. And the idea there is, how can you learn from the data that is being collected without sacrificing privacy? And that was also mentioned by the speaker from Bosch. So these are the three areas that I will talk about. Just to set the context, we know just that 5G was designed to address very diverse use cases across many applications, to autonomous cars, and also the sensors that was talked about, as well as while you're driving in the car, everybody needs broadband connectivity because of entertainment, productivity, and so forth reasons, which was also alluded to by Michael. So the 5G standard actually addresses these diverse requirements of ultra reliability, low latency, massive connectivity, and also very high capacity. And a new standard was defined, which sort of looked at different parts of the spectrum to address different requirements. So very low band spectrum, which had very broad coverage, to address things like, how do we connect large number of sensors to the system. The middle band being more tolerant to reliability and latency. And then finally, very high millimeter wave bands for extreme capacity and throughput. So there is a lot of effort on 5G to address the diverse requirements, but as we know that 5G by itself is not enough. So I'm not going to talk to the millimeter wave slide that I had earlier, because I think, I will talk to the other forward-looking topics more. So as we said, like, okay, a new standard is there. Now, what is it that we can go beyond? So I want to talk a little bit about the problem of co-design of wireless autonomy and how AI plays a role in here. And for that, actually, I want to highlight a collaboration that we have with University of Pennsylvania as part of Intel Science and Technology Center. And the goal of this center was to basically develop technologies which will enable autonomous system to operate on wireless networks, which is actually a very challenging problem, but it's a worthwhile problem to solve, because the fact that while autonomous systems connect with each other on wireless networks, help them do better or basically expand their scope and so forth. So if you can address the challenges of enabling safety critical autonomous system over wireless, then you have actually really unleashed the potential of these networks. So in this center, we focused on the issue of co-design of autonomy and wireless networking. And the view was that wireless network should also be treated as an autonomous system and not really a static system, because it's constantly being reconfigured and so forth. And then the issue is, how do I take two autonomous systems and design them together to deliver on the stringent requirements that you have, the safety critical requirements that you have for these systems. And AI and learning actually plays a big role, because the complexity of this entire co-optimizing the system together is quite high. So how do you kind of design autonomy, wireless networking with AI is the problem which this center addresses. And I'll give one example of how this design might help you. So the idea, like if you actually take a control system and you want to support a control system over wireless, off the bat, people will give you requirements like, you need to satisfy 10 to the minus 9 reliability, and you have very low jitter and so forth. And the requirements for wireless networking can be very, very stringent. So what we want to sort of explore is, do you really need these networks to be designed with such high reliability? So the answer is no. If you feel that if a system that you're trying to control is very stable already, then you may not want to nudge the system or control the system that often. And you only try to control the system when it is far away from stability. So this example actually shows that we have a plant which we are trying to control, and there are sensors which are deployed, let's say in a factory environment, and the sensor reading are being sent to the controller. And if the sensor readings don't arrive on time, then the controller may not be able to act in time, and the system will move towards more unstable positions. So, but if you kind of think that, if a system is already stable, then I can actually afford not to report my sensor measurements that frequently, and the wireless scheduling problem then can make use of that fact. So the idea is that when I'm designing my resource allocation, or I'm deciding who I'll allow to communicate over the wireless network, then I try to take into account the control state of the plant that I'm trying to control. And by doing that, we've shown that by prioritizing those sensing measurements for transmission, that would really make a change to the control state. By being more control state aware, you can really relax the requirement that you have for reliability, because I can then afford not to send the packets that frequently, and I can still maintain my stability of my system. So this figure, which is being shown here, sort of gives this, different methods for controlling for resource allocation with different latency requirements. And as you can see that you can get a lot of, you can pack a lot more users while still keeping the system stable if your scheduling algorithm is more control aware. So in these results that I'm showing, we kind of know what the control dynamics are at the moment. And if you're aware of the control dynamics, then I can design my scheduling algorithm to be more aware of the control dynamics. But if, let's say, for most systems, it's very hard to estimate this control dynamic. So what do you do about that? So the thing we are trying to do in this area is basically look at reinforcement learning or machine learning techniques to really learn the control dynamics and then do the scheduling policy to account for those control dynamics. So by doing that, we can actually say that you can keep your system stable, but you can relax your reliability requirements quite a bit, which allows you to support much more devices than you would be able to support otherwise. So this is sort of steering towards different design philosophy, if you will, rather than kind of blindly designing wireless networks for very tight requirements. So that's one area that is of interest in this topic. Then I talked about the AI and machine learning for wireless, and as we saw that machine learning can help potentially to solve the complexity that is there in wireless systems. So as you talked about, right, there are so many cars that may be driving in a particular environment, and all of them need to connect to the central controller, or ship the data, or everybody in the car is actually trying to watch videos and being entertained, then the system complexity is very, very high. So how do you really manage this network to address the system complexity? And we believe that machine learning can be a big tool in designing end-to-end 5G or beyond 5G networks. And machine learning, this picture shows, is applicable across many, many areas of wireless networks. So not only the devices themselves could be more intelligent, they can be more cognizant of the network connectivity. When should I connect? When the connection is good or bad. I can design new air interfaces to take into account some of the problems of propagation, for instance, and deployment of infrastructure, as well as the applications you run over the infrastructure, could all be optimized through the use of AI techniques. So people are really applying AI as a tool across many applications. I give a few examples of where this could be useful. So the basics of wireless is spectrum. So I think one of the key areas where machine learning and AI techniques is being used is to really use it for enhancing spectrum use. Like, how can you improve your utilization of your spectrum? And DARPA, as we know, had a spectrum challenge, which allowed different teams to actually compete, not only compete, but really collaborate with each other to use the spectrum more efficiently. And they wanted to use AI techniques to be able to not only maximize my own throughput, but also make sure that I don't hurt other people's throughput. So this is one area where AI has been sort of, being applied. And then signal processing functions themselves, like, my equalization, my whole transmit receive chain can then be helped by replacing it by AI blocks, which will help me, simplify the design of these, of maybe a complex transceiver and receiver. And so there are some interesting results in this area which are trying to apply machine learning tools to signal processing functions. Then also we want to apply machine learning to end-to-end communication system design. So what is a communication system? It is really, I want to send a bunch of bits across the air, and then I want to design a receiver which will receive the bits and reproduce the bits correctly. So can I design an AI-based transmitter as well as an AI-based receiver, which allows me to reconstruct? I basically decides what I transmit and decides what I receive, or reconstruct what I transmitted without having errors. So this is also an area which people are very actively exploring. And then finally, I want to give a vehicular example of resource control in vehicular networks, where you want to be able to transmit from car to car or V to V, while simultaneously using the same spectrum for, let's say, transmitting to vehicle to infrastructure. So I may want to transmit my signals for my video while I'm also communicating between cars. So how do I actually come up with this policy which can make these two types of communication coexist better in vehicular networks? So a deep reinforcement learning type technique has also been applied and been used successfully. So these are just some samples of the ways in which you can apply AI, and I think a lot of people have observed different success. While there is some promise, there are some issues in the sense like, how do you address the fact that you don't understand AI systems well? Like, how do you know that I can trust the results of these AI systems and so forth? So this is a challenge which is ongoing right now. Then finally, I want to come to this topic of, I am in a car and my communication system is now better designed, but I need a lot of data to be available to me, not only for, watching videos and so forth, but also learning from the data that is being collected around me. So how do I collect, or how do I learn from this data without really sacrificing the privacy of the data? And this is something that, Michael, you pointed out, like we really need to figure out how can I actually improve my intelligence or derive a lot of intelligence from the data I'm collecting without really sacrificing the privacy of the data. So I think the first speaker actually alluded to this. The thing is, as was mentioned, basically the emerging devices and not only at the edge, but at the clients, which is, my autonomous cars, my drones, my laptops, and so forth, they are increasingly very, very powerful. So they're able to process the data locally without shipping all the data to the cloud. And as the privacy concern and the latency concerns and the bandwidth as well as scalability concerns become more important, more and more of this processing should happen locally. And the fact that we have all this rich compute and communication, sensing and storage resources at the edge can be leveraged for doing distributed learning. But the issue, so basically, what do we mean by distributed learning? If you compare it with the centralized method, currently how it happens, as you guys have said, is all the data gets collected centrally, and then this data gets shipped to a central location, and then lots of models are trained within the data center to develop models, and then the models can be deployed back into the system. This, of course, has some privacy concerns. So the other idea is that you keep the data local, the clients learn from local model, or the end devices where the data is being collected just process the data or derive the learning model directly from the data. And then instead of shipping data, you just ship basically some model parameters to a central server. So while each device can actually learn locally, you still want to learn from what everybody else is seeing, because my capacity to learn from the data is very local, and if I want to sort of learn better models, I would like to collaborate with other devices, and this collaboration might happen through the help of a central server, which is a federated model, or it may be totally decentralized, like I can talk to other devices in a peer-to-peer way. But the key is that I really don't share my data, but I share my learning, what I have learned from this, and I kind of share that in a private way, such that my privacy of my data is not compromised, but I can still learn better models together. So this is one sort of approach which is being studied quite actively, and Google has popularized it. So if you look at your smartphone, the auto completion or the text prediction is something which happens through this method. And then going forward, as we know that in some cases you may not have access to the central cloud. So how, let's say if I have deploying a drone swarm or a fleet of robots in an uncertain environment, then I need to be able to learn from them, learn from the data, and collaborate without really shipping data to the cloud. So these are some of the models that are being used, and that may help alleviate some of the issues, but these are not currently solved problems. So in some sense, this is the research that our team is doing in terms of being more clever in terms of how 5G networks are used in the context of autonomous systems and telematic systems, and do kind of co-optimize these systems together. Use of AI in the system across, both for improving wireless networks, and then having the end devices and the wireless networks be more compute capable so that it can learn locally from the data, so some of the privacy issues can get addressed. So in these topics, we are actually funding a center jointly with NSF. And this center really focuses on looking at the issues that I highlighted. So how can machine learning and wireless networking work better together? How can I apply machine learning tools to take into account wireless challenges and improve the performance of wireless networks? How can I design machine learning tools to utilize the spectrum better? And how can I support distributed learning, local learning, which is privacy preserving, better, while sharing my intelligence across the network such that I kind of meet the latency requirements. I am able to deal with the heterogeneity of the edge environment and so forth. So this is something that we are working on actively, and that's all I wanted to share today. I know it's not quite relevant for exactly all the questions, George, you asked, but it gives you an example of some of the research which might be relevant going forward. Thank you.
Okay, thank you, Nageen. So I guess Marcelino had to leave, and because we're slightly behind in schedule, so I think what we'll do is that let's ask everyone questions together. Originally, my intent was to just ask the panelists, and then after that, take questions, but we'll kind of take it from everyone. So whoever has an answer or has some thoughts, they can contribute. So, but first, let me say a few words since we're talking about privacy. A lot of times, everyone somehow feels they have a right to privacy. But if you look at the U.S. Constitution, there actually is nothing there saying that you have a right to privacy. Now, if you kind of close your eyes a little bit and kind of look at the Constitution a little more carefully, all you can come up with is that somehow it guarantees you a right to be left alone. Liberty. So it's not exactly the same as privacy. Okay, so that's the Constitution. How about the law? Well, a few decades ago, I think car companies realized that they're going to get in a lot of trouble. So they basically got together and signed some document, and it's still in effect, basically saying that all these transportation companies, they promise to be careful how they collect your data and be careful how they handle it. But there's really no enforcement and there's no big legal requirement. They just said they'll try their best. Okay, so that's where it is. And then what Michael mentioned, this GDPR is a little bit different. That is more like if you want someone's email, you want someone's phone number, you need to ask for permission, you have to opt in and opt that. And because California is a very progressive state, last year they rushed through this Quick Privacy Act, which is actually even worse than the GDPR. And because they fine you, they charge you money, all kinds of stuff. But they have cutoffs. So if you're very big, you have to observe it. But if you're very small, like a little businessman or proprietor, you probably don't have to observe it. But that doesn't really apply to this. So unfortunately, the privacy law in this country is very fragmented. So all you can say is that the category most people are most sensitive to is what they call personally identifiable information, right? That's kind of like maybe how tall you are, how much you weigh, your name, your mother's maiden name, when you were born, where you live, that kind of stuff. So that is very, very sensitive. So that of course, is the one that you have to be most careful of. And then also, they have carved out another piece from the HIPAA Act, which is basically health related. Are you sick? Are you in a hospital? What's your disease? Are you going to live or die? Who's your doctor? All that kind of stuff. So that is also very sensitive. And that relates to this as well, because of course, there's ambulances involved. You may take Uber to go to a hospital, all that kind of stuff. You may end up in a stretcher, whatever. So next to the PII, the personally identified information, the health one is probably very sensitive. Then there's another group of laws that deal with finance and banking information, moving money here, there, who owns it, how much, blah, blah, blah. Again, you can kind of tie this to transportation in some sense, but not directly. Then there are other parts of it that have to do with IP that's carved out. In other words, any kind of patented type information, that kind of stuff. There's some kind of privacy and protection there as well. But overall, those are non-technical stuff. So what can we do as engineers? So one thing that people have thought of, and I'll just propose to you, is that at the sensor level, for the longest time, we've been doing kind of a brute force way of doing it. We just turn it on and collect everything, okay? This is very bad because first of all, it accumulates lots of stuff. And anecdote, you've heard this kind of stuff. When Google went around taking pictures of people's houses, people sued them. And then in the end, the government said, well, it's public. I mean, your outside of your house is public. So they said Google is allowed to take a picture of your house. But they added an extra thing, which is that you can also write a letter to Google saying, I don't want it. So in that case, when they do Google Earth or whatever, and they look at your house will be blurry. Okay, so that's their contribution to privacy. They will not eliminate it. They just make it kind of blurry. Then there have been other instances with this Google thing where, they took a picture of someone and the person was naked or the person was dead or whatever. So, that kind of stuff. So what I'm trying to say is that maybe it's the wrong approach to use so much data. Okay, so at the sensor level, there have been different proposals. Technical solutions are not yet there, but here are some proposals. Okay, so when a car is moving down the road or truck, instead of like trying to photograph everything, right, image it with a camera, trying to do LiDAR, trying to do radar, you have some kind of AI or some kind of clever thing sitting there looking to see if there's anything interesting. So one school of thought is something called event-based. Okay, you sit there and, oh, nothing interesting happening, nothing moving, nothing bright, nothing dark. Don't bother recording it. Whoop, something's moving, something's fast, something's blurry, something's bright, record it. So that's called event-based. So in between, you're doing nothing. So that's good, right? Less data. Then there's another thing called ROI. This is not the financial ROI. This is ROI where it means region of interest. So if I'm a car moving forward, clearly I'm not really too interested in the left side and the right side. So I can kind of ignore it to a first order. So this, I use all my sensors, and as I said, in the GM Cruise, there's 38 sensors. Instead of having them on all the time, collecting data, sending it up to internet or to 5G, whatever, you sit there until you see there's a region of interest, and then you focus in on it. So in other words, you selectively collect data either based on period of time or based on physical location, the direction. So that will also reduce it. Then of course there are more fancy methods, semantic ways of scanning, where you do fancy AI and calculate exactly when and where and how you need to do it. And then there's also something called shared intent, which is basically instead of you figuring out what to do, we all agree that when we get to an intersection, you go first, I go next, he goes next, then she goes next, things like that. So again, some kind of sharing of data. This will also minimize privacy issues, because then we don't need to care who is what exactly. Okay, so there are technical solutions, but we're not really there. Okay, so let me ask just a few questions. Anyone who wants to answer can answer, especially if they think they have something to contribute. Most of them don't really have answers, so I'll just ask them and we'll just discuss it. So I think the first thing that comes up is, I want to ask is, who owns data? Anyone want to try answering that? Who owns the data?
Yeah, I would say currently the user does not own the data, but it would be nice if the user could monetize the data. Like if you use my data, I should get some compensation for it. I'm just throwing that out as a possibility.
Any other thoughts from anyone? No? Okay. Well, I can kind of give you some thoughts on that as well. So basically, within autonomous vehicles, there are different kinds of data, right? And different people have talked to it. There's something that's basically internal to the car, right? Something's in there. Then there's second one is something outside the car. Then there's something high up, kind of traffic moving. Then there's another one, which is kind of the communication network. So as you can see, basically, if you call ground level to tree level to forest level, the higher up you go, the less protection you have. It's further away from you. But the good thing is that it's now blurred out because it's collective data. So I think generally most people probably agree, if you generate the data, it's yours. So in other words, if you tell them my name is, I was born on this date, this is my credit card number, then it's your data. Okay, so you probably should have a big say in it. On the other hand, if the sensor guy is just collecting data, storing it someplace, or the module guy is using it to do some actuating someplace or whatever, then the further away it gets from you, even though you told them to do it, then you kind of lose control over it. So I think that's kind of how it goes. And as Nageen said, that leads to my second question, which is that, okay, regardless of who owns it, what do we do with data? Because it clearly has value. So here are the proposals. You can say it's free. Okay, whoever gets it, do whatever you want with it, whether it's right or wrong, it's free. The second way is that, no, you have to buy or sell it. It's not free. And of course, corollary to that is that it could be bartered. So in other words, when you get into Uber and they ask you for information, they give you a discount because you gave them the information. Or they give it to Google and Google gives them a discount. Okay, so at some point there could be a financial angle to it. It's not just simple privacy. So as Nageen said very reasonably, it is not free. Okay, of course the argument from the other side is that, wait a minute, it costs me money to store the data. It costs me money to develop the algorithm. So you should pay me instead of my paying you. So then of course the way to do it is that it's probably a trade-off. Your intrinsic value of data, which is privately protected, and the fact that they put money into it, doing something to it, that helps you get to where you're going. So, probably some trade-off there. Of course, hopefully the startup people or whatever don't get too involved with this, because then you have issues like, wait, maybe this is information as a service. So it's not like a one-time thing. Maybe every month you have to pay the government or pay Google, pay Uber, or pay someone, or vice versa. Money needs to exchange hands because there's a service being provided. And then, of course, the problem is that, yeah, but it's my private data. Yeah, but I'm giving you a service, right? So that could be an issue. Okay, a related question. Anyone wants to answer it? So there's some value to it. There's some privacy to it. Who is the gatekeeper? Is it you? You need to protect yourself. Is it California? Is it the U.S. government? Is it the IRS? Is it United Nations? What is it? Who? Anyone have any thoughts? Who should be the gatekeeper?
For what type of data though? Like you mentioned UN, so definitely, as you mentioned, right, there could be different owners of the data. And people actually, like if you talk to telecom operators, that's their, secret sauce, if you will, and nobody wants to share those data, even though, the networks could be improved if researchers could have, get the data in their hand and start using it to build meta models, but it's very difficult to get that data. So yeah, I think, as you mentioned, like, people who generate the data actually find the data to be valuable, and they would like to derive the insights themselves, and perhaps a system that enables that would be a good thing, right?
But every year, all these consultants that come up with reports like telematics industry or computer industry, and to buy the report, you have to pay thousands and thousands of dollars to get the report. But all they did was get your data.
Yeah,
Right?
just sell it. Yeah, exactly. Yeah.
So I think, yeah, go ahead, Michael.
Yeah, from the business point of view, I've seen this situation happens that it's a negotiation between like OEMs and service providers to decide who owns the data. It's always part of the negotiation. Because everybody sees the value out of it.
So you think it's more of a case by case, free market type thing?
Right now, yeah, just nobody really, there is no legal decision of who's the owner of the data. So it's become the commercial.
Okay. Well, let me say one more thing, which I don't know if everyone knows. Like Google, Waymo, some of these early pioneers have said they don't want money to exchange hands. So if you go to Waymo, and I'm not sure about Tesla, but if you go to Waymo and say, I want your data. Now, if the data you want is like what kind of sensors I have, what kind of weather it works under, all that, they'll give it to you free. If the data you want is how many times did you have to take over human control, they would not tell you. How many people died because you hit them, they're not going to tell you. So anything like they could be sued for, they'll not tell you. But if it's technical information, they got gazillion, lots and lots of data. And remember, there's a huge amount of data. I don't know if you realize, in 1 hour, right? One of these cards can produce something like 4 terabytes of data in 1 hour. If you're sitting there collecting with all your sensors, blasting down the highway. So what are you doing with all this data? So I think by gatekeeper, I actually mean, like a toll road. Should the government sit there, or should a consortium sit there, or would you let a private company like sit in between? Like today, the bank will sit in between, and all they do is move money from left hand to right hand, but they charge you, right? So anyone have any thoughts on that? Is it government level, private level?
I think some laws need to be in place to protect people's private data. And also, I think as things move, I mean, I gave you an example of distributed AI, right? And if this can be made to work, then there is just many more people who can get intelligence out of the data that they own or they generate and so forth, rather than in today you have all the data being shipped to a few providers, and there is a lot of these AI intelligence services are owned by few people, and as you make this capabilities of learning from data in a distributed way, you may be able to break that a little bit, and you may have different participants who could either monetize the data or at least do more with their own data and so forth. The landscape may change a little bit. And so
Okay.
technology could help drive that. Yeah.
Well, here's another proposal. How about agree on a lifetime for each piece of data? So in other words, if I authenticate, 5 minutes later it's deleted. If I take a trip, 24 hours later it's deleted. Assuming there's no accident, nothing really bad happens. What do you guys think? Is this hiding data? Is it distorting it? Because now you can't sue them, right? The data's gone. But is it worth it if we get our privacy? Like you take Uber and you know that 2 days later, there's no record you ever took them. It's deleted. Is that an acceptable solution?
Yeah, I think it's at least a part of the solution that some of the data that we can make sure it only exists for a short period of time. But on the other side, are those data needed for the future use? You may need some of the history data for analysis, and probably the data collector probably don't want to do this.
Okay.
How to prevent that? Yeah.
Yeah, that gets to my next question then, and I'll come back to you, Nageen, which is that, okay, then does this concept of anonymization, how about if I take data and if there's no need to know it's you, how about if Uber says every week, these are the people who travel in my car, or the bank says, these are the people who use my credit card inside your car, but they don't say who it is. Is that okay?
I think I'm not very expert on privacy security in that sense, but there can be attacks which can, even you anonymize the data, but you can actually reveal, the data can still reveal your identity, for instance, and so forth. So I think a lot of work still needs to happen in ensuring that anonymization actually works. So there are, new privacy metrics being introduced, like how do you quantify privacy, how do you measure it, what is a privacy leak, and all these things are pretty important to sort of understand, because you can do very bad things with the data. You can do very bad things with the AI, as we know, and these things are brittle and not well understood. So having security and privacy being a factor in this area is quite important. And I think anonymization on its own may not be sufficient.
Okay, here's another possible solution. Today, most things are hardware. So at one time they had a cloud, right? Everything went out to Amazon, AWS or something. And then people said, well, maybe that's not good. So then people said, how about you do your own private cloud? So, your own factory or your building or your town has one. Then they said, well, but some things I need to go bigger than that. So then today, the latest thing is called hybrid cloud. It's partly private and partly public. But then there's been this concept, two different concepts that have been kicked around for a while. So one is called software-defined networking, and the other is called network function virtualization. So SDN basically says that instead of having this hard drive store your data, instead of having this server farm process compute stuff for you, I have a layer on top, which is programmable, that creates a custom application for you that is not dedicated to a particular hardware. In other words, it's not one-to-one, right? So that's more like SDN. Then there's NFV, which is like, hey, maybe I can even pretend there's a server farm when there's actually not a server farm. So you can see that if I have enough software, I can actually recreate the whole thing where there is not even anything close to a one-to-one, where basically it's a virtual thing. And I can do mirroring, I can do all kinds of backup, I can do all kinds of encryption, all kinds of fancy stuff where you cannot tell where it went, right? With hardware, I can tell that, oh, your data's in Virginia or it's in Shanghai or something, right? With SDN, it's also there, but it's not on a particular, piece of equipment. With NFV, I don't even know where it is. It's somewhere in there where they are computing and massaging around. So what do you guys think? So would this help privacy if we went that way? SDN or NFV or something like that?
I think these are not related topics in my view. There is one, of course, you want to be able to not have dedicated hardware to, one function. I mean, you basically want to use your hardware for multiple purposes. And it sort of complicates the security issue more. Like if you have everything in a box, I think it's perhaps not sure. I guess I'm not like, I think there are
Oh, you can lock the room, right? You lock the room and there it is.
but
Safer.
having it software, and whether the software is protected and so forth, opens up new issues in terms of security for sure. And privacy, I guess I'm not 100% sure. But I actually wanted to say that getting the essence of the data and processing the data as it is generated is an important. I think you mentioned this very early on, right? So
Yeah.
just kind of basically processing the data in an intelligent way to extract the essence of it is actually important. Now the thing is, the essence of it may depend on, the data may have multiple uses. So you may get the essence for one particular use, but the data might be useful for some other purposes. So that basically becomes attention. What do you throw and what do you keep is still attention. But definitely, as you mentioned, right, you don't need to process all the data. And also there are metrics now being discovered to say which part of the data is important, and I can only look at that data. And definitely you want to move in that direction, because even if privacy was not a concern, your even 5G, 6G may come along, but the capability to move this loads and loads of data, which is going to get even worse, is not going to scale if you don't process the data locally. So I think that's one of the key sort of innovation area where innovation is needed.
Yeah, with the AI for the longest time doing training, right? So basically the thought was, if I put in enough random permutations of different stuff out there, then my machine will get really smart. But it turns out this is not true, right? So the most common example is the one where they did facial recognition. But the problem is that something like 99% of people are white, right? So then they realized that when they use this on non-white people, it didn't work well. For example, they took the members of Congress and then, tried to see if there are any criminals in there. And a whole bunch of them turned out to be criminals, according to the facial surveillance, because they match FBI pictures and all that. So that means that despite all their millions and millions of training exercise, it didn't really do anything, right? And then another related thing to that is interesting too, that such as in China, they do facial surveillance, and also in Europe. But then today, people use the COVID-19 mask, and most of those things now fail. It cannot recognize you. So then you have to say, wait a minute. We thought we were training on the face, but it's not. And it turns out that when you smile, your mouth, your cheeks, they move a lot, right? And they move the most. So that's the easiest part to train on. So when you did all this supposed training, you were actually matching up people's mouths, not really their face. So now they got smart. So what they're now doing is that they found out that they're going to change their algorithms to look for the wrinkles in your eyes, in your forehead, above your nose, because everyone gets wrinkles, right, between the eyes and above the nose and the forehead. And they think this will be really, really accurate. So what this means is in the future, you probably need to put on lots of makeup or something, get rid of all those wrinkles, and then they won't recognize you, right? So, but my point there is that, again, what I said earlier, sometimes it's not brute force data manipulation that works. That it is, people have this self-conceived bias as to what they think will work. Okay, let me ask another question. In some countries, I'll just pick China as an example. They have cameras every 50 feet, there's probably a camera. So,
Right.
hey, if I'm driving in Beijing or Shanghai, why do I need camera on my car? I just need to have some AI system that hooks into all the infrastructure and borrow everyone's security camera. And basically, they can tell me what happened in front, what happened behind, what happened a mile away. What do you think? Is this a privacy issue, or is this clever, or is that?
No, I think, oh, sorry, go ahead. Maybe Michael had an answer.
Yeah, well, unfortunately, those data is not sharing. That the cameras settled by the government, they won't sharing the data with the companies that needs this data for the travel for the vehicles, so that all the cameras that although we have all the data, probably we already have enough data to share, and unfortunately, from the business point of view, it won't work.
It will not work?
No.
Okay, yeah. But for people who are curious, right, you might say, wait, all these cars that I see, like Waymo wandering down the road or Tesla, are they taking a picture of me? Yes, they are. But it turns out that the resolution is poor. So that today, the camera on all those cars cannot actually recognize you. Okay, it's not at that level. But in theory, in the future, it could be. So the thing is that, is this something we want to block? Because with traffic light cameras, you notice that every traffic light, they know if a car is there or not. So there are two basic ways of doing it. So one way is through inductance. They put coils under the road. So when your car is sitting on top, it can detect there's something there. Okay, but that's a problem because I have to dig a hole, put in wires, and then when I resurface it, I have to dig it back up, do it again. So a lot of places like in California, they use these cameras to see if you're there. So people have always wondered, wait, are you taking a picture of me? So because that privacy thing came up, they agreed that all these companies that make those traffic cameras will make it so low resolution, they can recognize that there's kind of someone there, but there's definitely a car there, but they cannot see your face. So by agreeing to that, you know, they probably have the technology to have the good resolution, but everyone agreed not to do it. So should we do that for cars too, that you don't really need to be able to recognize faces. You just need to know it's a human.
Yeah, I think this is a good idea to just limit the capability of you only gathering the data that you need, and you don't go any further.
Yeah, so there are actually people who thought of this already. So they actually have these detectors, sensors that chemically detect you. I don't know if you know that. So if you put it on the car, they can, you know, as long as you're not like, if you're like a mummy, completely covered up, they cannot detect you. But if your face, your skin, your arm is out, they can actually detect that there's a living thing there. And it's very accurate. So they can use it on a car to detect there's a dog there, there's a pedestrian there, all that without a camera to take a picture. They detect this chemical thing, as opposed to a picture of a human or a dead human, you know, things like that. So that is a good thing. But most of the big companies are not doing this. Most of the big companies are still very visual. Okay, so let me ask one more question, which is there are three big automotive markets in the world, right? North America, Europe, and China. So what do you guys think? Is it okay to let them diverge? Because like China is all excited about C2VX. They'll probably be first to implement.
I see.
You know, because China is very government controlled, right? They know what's best. They want to go there. US is always like, there's always a group of people that want to let the market decide. And as I told you earlier, those guys working on 802.11p don't want to do CV2X. And, you know, Waymo, Cruise, Tesla don't want to do it either. And then Tesla says, we're not doing LiDAR. Everyone else is doing LiDAR. They said, we're not doing it. But of course, Tesla is also the company that had like 4 people kill themselves by crashing into trucks, right? Like the famous case where the Tesla crashed into a big rig. When they looked at the data, apparently the car realized that there was a truck there. But the algorithm said that, yeah, but it's not a truck. So the algorithm told them that that's the sky. So it kept going, crashed into it, and the person died. But everyone else says use LiDAR. But I don't know if you know, but one LiDAR package with like 64 spinning lasers, just that LiDAR package costs $80,000. Just for that thing. And it's very complicated. It's spinning and all this. So it's very delicate. You know, if you have an earthquake, if you hit a tree and whatever, you probably break the whole thing. Now, there's some people came out with a solid state LiDAR. Very cheap, few $100s, but very low resolution, very inaccurate. So that's why Elon Musk said, this is crazy, I'm not doing it. So he doesn't do it. You know, he mostly uses cameras and using radar. So again, my question is, should we let the different, you know, the 3 big regions do whatever they want? I mean, like, of course, the ultimate solution is if the whole country has only one kind of car, one size of car, one grid, everyone just rents that same car. That's the best. It would be very, very good. Get rid of the 90-some% accidents due to human error. But then you don't get to pick your red car. You don't get to get your convertible, right?
George,
So what do you think?
hey George, can you hear me?
Yeah, yeah.
So we have like 4 minutes, and there are a couple of questions from the people
Oh, okay.
as well.
Oh, sorry.
So
Okay.
maybe we should take those couple of questions, and we don't have much time as
Sure.
well, right?
Sure, sure. Can we extend it a few minutes, you think?
Yeah, we can
Probably,
extend it.
yeah, I probably need to
Okay.
stop at 8. Yeah, I'm sorry here.
Yeah. Okay. All right, go ahead.
So
I didn't
yeah,
realize
so
that. I'm sorry.
let's take a couple of questions. So I have one question from Dave. He says that how is it possible to prevent a car from intentionally uploading bad data to cause accidents? Something similar to malware.
Yeah, so actually, I guess this is a very active area of research in terms of, there are ways to kind of protect against malware being uploaded. I mean, algorithms, even in AI algorithms, you're trying to make those algorithms more robust to, malicious users. You're trying to come up with, secure environments where you can actually process the data, where you can attest to when, whoever has loaded the data is doing the right thing and so forth. So this is a very active area of, research in terms of protecting against malicious users.
Okay. And then there's another question from Hamming Jin. He says that he asks that, do you know if the 5G bands are segmented to different purposes? For example, URLC, entertainment, etc. Please elaborate. And there's also a follow-on question if it's possible to assign privacy grades per band.
I can answer it. There is no segmentation of the bands for a particular application. It's just that some bands are more naturally suited for, let's say, very long range connectivity, and you may just purpose those bands that way. But it is no like hard segmentation of the bands for a particular purpose, I think. Yeah.
Well, it's related to the question I asked because Huawei in China, of course, they're one of the leaders, right? And they picked a particular part of the spectrum that I understand is not available in the US. So today you hear Verizon, different companies bragging they got 5G, but the US 5G is actually 4G plus. It's not really 5G, and it's a different part of the spectrum. So by going by the physics, the higher frequency you go, the broader it is, but the shorter range. So if you go very, very high frequency, you probably need like an antenna every 500 feet or something like that.
Right.
Which is good in the city, but not good, outdoors. So again, this is what I was saying, that maybe let the country do their own thing.
Then you have
We
the
have maybe one
CDMA
question.
2000 and so forth problems. But anyway, go ahead. Sorry. Amit.
Sorry, no, I was just saying that maybe we'll have one more question, then we'll call it.
Well, how many
Because
are left? Do you know, Amit?
I'm just asking if anyone
okay.
has a question. I think all the questions on the chat forum are done. I think Dave has been posting a lot of questions. He had one question before as well. Is like if a customer does not want their car connected to the internet for privacy and security reasons, do you think they'll still be able to buy a self-driving car or kind of operate it or whatever? Like not connected to internet, but you can still do a self-driving car.
Well, it depends on what functions the car provides. If you want an autonomous,
I can give an answer of whatever it's worth. I mean, there's some concept called platooning. I don't know if people know about this. It was an early idea where it's only autonomous to the extent of a group of cars. So one car will be going to San Francisco, and you also want to go. So if you agree to go with him, he'll be the lead car, and you can be like 2 feet behind him. And they've calculated you can do maybe 8 to 25 cars all together in one nice little compact thing. So I imagine we could do autonomous cars at different tiers, where there are people who are like masters, they can do everything, go everywhere, and then there are other people who just have to follow other people. But in exchange, you don't have to tell them much. So maybe that's a possibility.
I want to say one, maybe I can
Sure.
add an answer. So the expectation for an autonomous car is that, I mean, yeah, you may need the connectivity for downloading some software and so forth, but the car should be able to fall back on its own, even if the connectivity is not there. Like it shouldn't rely on V2X for autonomous driving, but of course the performance and the safety might be improved if you actually make use of this. But I think there is a method, or at least the desire is to fall back without having connectivity, being able to operate without having connectivity. So I'm not sure whether you can purchase a car or not, but you know, you definitely, I think the desire is to be able to fall back to onboard, you know, operation as opposed to connected operation.
Yeah,
Okay.
we didn't get to that, but actually there are other things too that we didn't get to, as I said, where you can use unlicensed part of the spectrum, right? Do whatever you want. And there are also different algorithms and stuff that do not require GPS. So if you are willing to kind of like not be too accurate, like not know exactly where you are, you know, not exactly know how fast you're going, all that kind of stuff, it is possible, I think, to be a completely self-contained, where you're not talking to anyone. But that doesn't stop them from looking at you from outside and trying to measure how fast you're going and trying to guess who you are, right? And you have a license plate. So I'm not sure, I mean, unless you're like completely black with no license plate and nobody can look inside your car, that would be a different thing.
Okay, I think that's the questions I had from the chat window. So now maybe we should, I guess it's time to wrap up. George, you have any final?
Yeah, so I want to thank the speakers to come here and help us today. And Marcelino's gone, but thank him, thank Michael, thank Nageen, thank all the other people who participated. And you should be glad you don't have to listen to the president. So I hope you learned something, and I hope this was a productive thing. If you'd like to give a talk to CAS Society, please contact one of us. Just go to our website. If you have any comment on how this one went, what you liked, what you didn't like, what you thought was bad, need to be changed, send an email or something to one of us, and we'll see what we can do about it. So thank you very much for your time with us today.
Thank you. Thanks a lot.
Thank you.
Appreciate it. Thanks very
Yeah,
much.
really appreciate it.
Bye-bye.
Okay, bye.
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 Bye.